Alright, good afternoon class. This is Simon again. And in class today we actually got to do we started atmosphere, and so I decided to wrap up that atmosphere discussion by concluding using this forum. Okay, and the thing that we ended on was the alternative to CFCs, and we said instead of using chlorofluorocarbons, you can use hydrofluorocarbons. Now the benefit is that you won't have to deal with the production of chlorine radicals. That's one major point. The other point is that the carbon to fluorine bond, it should actually be carbon, the carbon to fluorine bond is stronger than the carbon to fluorine bond is stronger than the carbon to chlorine bond. So you're less likely to get radicals. Okay, that's C to F carbon to fluorine and C to Cl. Alright. Now it doesn't contain hydrochlorofluorocarbons. It does contain chlorine, which is something slightly different. However, because you have hydrogen involved, it leads to a shorter lifetime in the atmosphere. So that helps in the overall scheme of things, because you don't have these, I don't want to say dangerous, but these type of species perpetuating the atmosphere. Okay, so the compared to HCFCs compared to CFCs, HCFCs only have about 5% of the ozone depletion potential. Alright, now the carbon cycle, some of these things you would have encountered not only in biology, but just, I guess, in your secondary school tenure. Carbon cycle is fairly straightforward. It just shows the movement of carbon. We know carbon is involved in plants. For example, glucose C6H12O6. That component is also found through things like lignin and other things that make up a plant. When it dies, it gets involved in fossil fuels, which can then be used as a fuel to produce carbon dioxide. Plants also respire carbon dioxide as well as oxygen. But it's important to look at how this CO2 would come back down from the atmosphere, and plants is one of the only sources that would pull this carbon dioxide down. So it helps to maintain the carbon balance. It is about carbon, as the name suggests. There's something called carbon dioxide, or something called sinks. Okay, sinks are the things that's going to help to remove the carbon dioxide, and plants is one of the major components of that. Alright, and the idea is to keep that balance, kind of like an equilibrium. Okay, so if you have too much carbon dioxide in the air, okay, it can actually be removed and become something called carbonic acid, which would leave in precipitation, things like water and so on. This carbonic acid, although it's bad for rocks and other things, it can it's going to help to keep that balance. So really, what I'm saying is that the carbon cycle really is just a big equilibrium, or the Chatelet's principle. So it does what it needs to do to maintain that balance. Okay, if it needs the gaseous carbon dioxide to become in liquid form, it will do that, so that the carbon is evenly distributed throughout both the atmosphere as well as the ground level. The greenhouse effect. Alright, now some of you perhaps would have maybe families that have gardens and they'll call it a greenhouse. Well, what we call in the Caribbean greenhouse most times is not exactly a greenhouse, at least in the strictest sense of the word. Some of you, maybe I know a few people in LTA that has some, but it's really just like a glass dome. And what that does is it creates a warm climate, not climate, but a warm environment. Because if you can follow my cursor, the sun comes down, and these greenhouse gases, they're not ozone, but the greenhouse gases, it provides kind of like a barrier, so some of the species can get out, not species, some of the radiation can come out, but not all of it. Okay, some of the radiation doesn't make it all the way out, because the greenhouse gases can actually reflect some. So you see right here, it's bouncing off, and so on. So because it's being reflected, It's going to reflect back down to Earth and be absorbed and so forth. And the challenge with that is that it actually can result in the everything below the greenhouse gases being a bit warmer. All right. A common example of a greenhouse gas phenomenon is if you park a car and you leave the windows up, okay, and it's in the sun, the car gets very hot. Okay, because just like the greenhouse gases, the car windows act as a type of barrier, just like the greenhouse gases do, and the radiation would come through the window, but it has difficulties. All of it does not come back out. So the net effect is that the inside gets really hot. So in terms of the greenhouse effect, you have short wavelengths of visible light passing through the medium, and they're unable to pass back through. Okay, so it results in a higher temperature. Photochemical smog. So smog comes from a combination of the words fog and smoke. But it's important to note that you have in the presence of smog, you have photochemical reactions going on, and that would include reactions with nitrogen oxides, VOCs, which comes from exhaust emissions. Okay, now this can also include things like peroxyacetyl nitrate or PAN, and these things become extremely irritating to the respiratory system, and you know that there's some countries that struggle with that. So in terms of photochemical smog, we should know what it is, what it's formed from, and the effects that it can have on individuals. Global warming is a term that folks use to describe the general increase of the average of the Earth's temperature, the Earth's atmosphere. This is a very controversial topic. There are some folks that don't believe the world is really getting warmer. But for the sake of the syllabus, you need to be at least exposed to the fact that there are folks who think that the world is warming and that we are responsible for it. Okay, this has a very political dimension because there's something called the Kyoto Protocol, there's the UNFCCC, and different conventions that would regulate climate control. For example, the Kyoto Protocol, it actually gives developing countries what they call carbon points or emission points or cap and trade. You probably don't know what cap and trade. But the idea is that, let's say all the big industrial companies got 50 points. Okay, and you only have 50 points of emission to use. If I don't use all my 50 points, but let's say China used all its 50 points, then it means that I may have some points left back that I didn't use for that particular period. So what I can do is I can actually sell my points to China because I didn't use them all. So really it's just a way of incentivizing reduction of or control of emissions. But some people think no, it's just dabbling in countries. That's not good. But some effects, you can have lead being a part of combustion of hydrocarbons. Sometimes lead was used as a component of fuel, an anti-knocking agent that prevents knocking in engines. And lead is particularly harmful because it can cause things like insomnia, which means that it's difficult to sleep. Carbon monoxide, we know, is very dangerous because it's not only colorless and odorless, but it binds to your hemoglobin in a way that's more aggressive than oxygen. So anything lower or anything about 400 ppm and higher can be fatal. And we looked at ppm in the other lectures, so we can look at them and see. Sulfur dioxide, we know that it's also a component of coal and crude oil. We should know the difference between coal and crude oil. Crude oil is the process of fossil fuels that form in the sea or liquid, whereas coal is formed on land. All right. Sulfur dioxide can damage your respiratory system. You can get two types of acid if it was to form acid rain. Okay, H2SO3 and H2SO4, and that can be very detrimental. Nitrogen does the same thing. It's also an acidic gas. It combines with oxygen to form nitrogen monoxide, which can go on to form nitrogen dioxide, which can dissolve in the water to give acid rain or nitric acid. But nitrogen oxide is a primary pollutant, okay? Whereas nitrogen dioxide is a secondary pollutant, and we should know the difference between primary and secondary pollutants. Okay, primary pollutants are formed directly from combustion, whereas secondary pollutants need to be oxidized. Okay, so here shows an example of your you forming your acids. Okay, so you have nitrous and nitric acid. Nitric is the second one, nitrous is the first one here. But together you see how these two gases, which are products of combustion, can take part in the formation of acid rain. And this acid rain then becomes particularly, later on we'll talk about the acid rain. But volatile organic compounds, they are just organic compounds that are very volatile, and they're involved in things like the formation of smog, as we spoke about earlier. So you see pan coming back into play. Organic compounds are particularly dangerous because they're good solvents like dissolve like. Some of them are carcinogenic. For example, benzene is a carcinogen, and so on. We spoke about primary versus secondary pollutants a moment ago. Examples of primary pollutants are carbon dioxide, carbon monoxide, sulfur dioxide, and nitrogen dioxide. But if you further oxidize these things, it becomes secondary pollutants. For example, nitrogen dioxide, ozone, and pan. Now here is your nitrogen cycle. It's similar to the carbon cycle. The only thing is that in terms of getting it down from the atmosphere, we use something called nitrogen lightning fixation, as well as nitrogen fixing bacteria. So here you have denitrifying bacteria, and you also have nitrogen fixing bacteria over here. And you should know the difference between them. It's useful to know an example of each one. If in biology, perhaps you touched on it already. And then different things like mineralization, these processes, we should be aware of it. Here you also have esterification, and over here you have pharma green and pharma brown. Now acid rain, I said we will talk about this. If you have these acids that are a result of the oxides of nitrogen and sulfur, it can actually have a significant impact on the pH. Now, it may in some cases cause it to decrease as low as 4.0, which is 10 times more acidic than it was before the components got involved. Now, the challenge with these oxides is that they can travel very far. Okay, so that's problematic because with the pollution that be taking place in one place, in one area, it may get transposed to an entirely different area. So how do we deal with this atmospheric pollution? Well, we want to look at alternatives. That's very important. You have nuclear, but every country you may not want developing the nuclear because of obvious reasons. Energy, solar, wind, hydroelectricity, and so on. So this is really, I guess you can say, the future. So it's your generation that will be responsible for executing that. Now you can improve technology. You have the LED bulbs, energy saving bulbs. The goal is to let our products be more efficient. Any appliance that you have that gets hot or makes a humming sound, it means that it's wasting energy to produce heat or sound. So if you can make the technology more efficient, you can actually get reduced your pollution. Mass transit, in some countries they promote mass transit. They promote something like ride-in. For example, Holland, business people, white-collar workers would ride their bike to work. And you have these bike, not just lanes, but you have bicycle roads. And what that does is it not only produces a healthier country, but it reduces emissions, which they can in turn sell to other countries for money, the carbon points according to the Kyoto Protocol. But you help to reduce your individual pollution, because if 1,000 persons are riding, then that's 1,000 less potential vehicles on the road. Sequestering, the idea of sequestering is just taking greenhouse gases and incorporating them into more stable compounds. For example, carbon dioxide can be meshed with metallic oxide to form a stable carbonate. Filters, you can get rid of larger particles using electrostatic precipitators. Here's an example of one. The idea is you pass it through, it picks up a negative charge, this is the dust, and it gets attracted to a positive plate. Here's an example of an air washer. It really just cleans the air as well as altering the humidity. And then finally you have wet dry scrubbers, and then you use them along with fumes and furnaces and so on, and it helps remove particles that are bigger than 10 microns, which you know what it is. All the best.